We were basically looking at the pandas in the previous session, and today we'll be continuing with it. So meanwhile, if you have any question related to what was discussed in the previous session related to the pandas, please go ahead. All right, so let's bring the pandas in and let's start looking at the pandas, okay? All right, so this is how we bring in the pandas. Now, we want to create the multi-index concepts. So there is an option called the multi-index. In the sense, a row can be a part of several sub-rows. This is what is called as a multi-index. So index is the thing which actually is used to address a row. So how do we create multiple indexes by using what is called as a multi-index is what we are going to see today. All right, so let's start with that. So let me try to create the indices first. So this is our first example of multi-index. So I'll call it as my index. My index is equal to, so we'll try to create a tuple inside array. So, right, so tuple means you have to enter the values inside the parenthesis 2020. Comma, say, let me write 2010. Then I'll write the remaining sets over here. This is comma 2020. Let me write we'll repeat the same thing for another city. Let us say that is (2020) and another one. So by this time, it should be very clear to you that we are trying to represent something related to these cities. There are three cities, Bengaluru, Mangaluru, Udupi. And we are trying to represent some data of these cities, okay? Some data of these cities corresponding to 2 different years, right? So this should be very clear by this time. Okay, now let me try to, let me try to do this. So this is what is my index. I'll also bring in the population. Right, so let me try to make it an index, a list for us. So let me write some numbers here: 9, 5, 6, 7, 8, 9, 9. Then 8, 7, 6, 9, 8, 7, 6. So these are the 2 values corresponding to Bengaluru 2020 to 2010. Okay. Similarly, let's go to the other city of Mangaluru. This should be say 2789876. All right, then we have another number that is 1890987. We have, right, corresponding to Udupi 1897766. Okay, and 970966. Okay, so these are the 6 different values. Now you see, I'll create a series first. Okay, my series. So my series is equal to, let's create that. So PD dot, we know that how to create a series. All right, PD dot series. I just have to tell that, put the population over there and give me the index is equal to my index. All right, so this actually creates a series now. Let's try to look at the series. Right, so you see that Bengaluru 2020, both are actually considered as an index altogether. So tuple becomes an index over here. Similarly, the other data also we can see that Bengaluru 2010 a different value, Mangaluru 2020 different values. But how do we visualize this in a different form? This doesn't look like it's a series now, right? So series in the sense everything looks like every entry will have an index, right? That index is the one which is used to identify each of the elements of the series, which is a column. This is what we have seen earlier, right? So now our next approach is that let me try to convert this into a different form now. So my index, this is already existing, equal to, I'll try to use a converter here. Okay, so PD dot, there is what a converter called as multi-index. Okay, dot, and I'm creating a multi-indices now. And on what basis you are creating that? You can see that multi-indices, right? Multi-index dot, you can see every index that has been used for the series is a tuple. So you have another function here that is from from arrays you can do that, from frames, from products, from tuples. But as of now, you can see what we have here is a tuple. Okay, so let's use that. So let's come down and use from tuples. From the tuples, obtain the multi-index is what I'm saying. And from where you get, it's actually where you have saved the indices in the form of tuples. Line number 2, it's my index, right? So I just have to write my index. All right, so this actually creates that. Now let me check the my index once again. Right, so it is a multi-index now. You can see here, right? So every tuple has been converted into a multi-index now. Now I can use this, right, to change the indices of the series which we have obtained. So you can see here, what is my series output of this? So I don't see multi-index being represented over there. There is no multi-index, right? Everything has a unique index. Now the multi-index comes into picture. What I have to do here is that I just have to convert my series into once again, I need to perform what is called as a re-indexing, right? So this is how you do that. So my series equal to, do the my series itself. This is my series dot, there is what is called as a re-index. Obtain the indices of this particular series using the most recent index which you have formed. Okay, so how to get that? What's the name of that? It's my index. All right, so this actually creates the new my series. Let's visualize that. Okay, so my series is, now you see, compare the output of line number 5 with this. So line number 5 output, which you see here, this is actually a my series, but multi-indexing is not visible over there. What do you mean by actual multi-indexing is this. So Bengaluru city, 2020, what happened? 2010, what happened? So you see, there are multiple indices for this. Bengaluru takes you to the first 2 lines. Mangaluru takes you to the 3rd and the 4th line. So whereas the Udupi takes you to 5th and the 6th line. So inside Bengaluru, what you want to see, you have to use another index to prove that, 2020 or 2010. Same thing, Mangaluru also two sub indices are there. So this is what is called as the concept of multi-index. Okay, multi-indexing means, right, accessing the variables by using not a single type of index, you have to use multiple indexing. So this is what is the next level that we were talking about in our previous discussion. Okay, now how to visualize this? I'll just give one example over here because many more things are going to come at a later stage. So I'll just type my series. Okay, you can access that using, I just say all the rows corresponding to 2010. Just show me. This is what I'm asking. So you see, it actually goes back and reads every 2010. This number, and this number. All right. So that is the first concept that we are going to discuss today. Right. After that, now you can consider this multi-index as a special dimension, right? So now you know what is a dimension. X-axis, whatever you plot is along that dimension. Similarly, if I have a y-axis, what I plot along that is the next second dimension. So two-dimensional function. Similarly, the multiple index or multi-indexing can also be considered as an extra dimension. So what do you mean by that? Right? So I'll just try to show you now, right? So this is, let me call it as a, say, let me try to call it as population DF, population data frame. In short, I'll try to write it as, right, population DF. This is equal to, see, there is a function called unstack. So that is the one which can be used quickly to convert this particular series, which actually has multiple indices. You can convert that directly into what is called as a data frame. How to do that? I'll show you now. So use my series dot. So there is a function called unstack. Just do this. Okay. Unstack is a function which we have used. Let me show you the population DF. So see, the 2010 and 2020, which were being used as an index, right? They were the indices in the series. They have been moved to the top. So two separate columns have been formed. Now also you're able to access the same data if you want. In Bengaluru 2010, what happened? You can see that. In Bengaluru 2020, what happened? You can do that. But the interconversion was pretty much easy for us, right? So this is what is the use. Now, I have a question. If I move from a series to the data frame, can I come back, right? So the answer is yes. So this is how. So unstacking is what you have done now. So you have to perform what is called as a stacking to come back. Let's do that. So that is population df dot. There is what is called as a, I think, stack. Yeah. So you can see there is a stack. Right. So as soon as I use this option called as a stack, right? Look at the result. We got it back. So just understand, unstacking means if you have multiple indices present in your series, it will get converted into a data frame. And if you have something in the data frame, you want to convert it back into the multiple index series, right? You can use a stack. So very important, right? That's why we are spending more time on this. Okay, let's do something more here. Let me try to add something else. Okay, so I'll try to update my this thing. So population DF, I'll try to update. This is equal to PD dot, I'm trying to create a data frame. Okay, PD dot data frame. Let me try to do something like this. I'll say there is what is called as a total value. And the total value actually comes directly from what we already have. That is called as, say, the my series, right? Because as you can see here, this is a my series. Okay, so my series is there. This itself is what I'm using now as my as a first part of my data frame. To this, I'll also try to add a new column, right? If you remember, you can easily add a new column, right? By just typing, give the name that you want to enter for your next column. So let me write. So this is the total population which we had. Now I'm talking about what is called as a senior citizen. So among this population, how much is the population of the senior citizens? So I actually need 6 different values, 2010, 20, 10, 20, 10, 20, and so on. So according to that, I'm supposed to write something now. All right, so I'll enter some of the values here. So 965638 is the population of senior citizen in the same order. Bengaluru, then 2010 for Bengaluru, then same 2 years for Mangaluru, then Udupi. So I'm writing in the same order. Okay, so this is say 8, 1, 2, 3, 4, 5. Okay, then we have the next number coming up that's corresponding to say Mangaluru, and then I'll be writing the values corresponding to Udupi. Okay, so that means this has to be 213699. Okay, then 178745, then 119898, then 90888. Okay, so this is what we have. Okay, so this is the other part which I am supposed to create in the form of right. I try to create a data frame so far. Okay, so just visualize this. After that, I'll write the population here. Let's visualize. Now you see, as you can see, this was our sorry. Let me just go back and show you where is that data frame. This was our data frame, correct? Previously, we had something like this. Okay, now I try to convert that into the data frame. So the first half, right, you can see the city name, then the years followed by the total was the actual data frame which we had earlier. But now you see, we added a column called senior citizens to that. Now, okay, I'm asking you a question, right? It's a quiz, all right. So I want you to tell me what is the fraction? What fraction of the population is senior citizen, right? Every year wise, in the sense, right? What I want you to do, I'll tell you quickly, right? I don't want these two columns, right? You can operate, so you have two options. First thing is that you can try to implement this, right? In a series, on a Pandas series, you can do that. Otherwise, you can even implement on a data frame, left to you, right? I want you to display only one thing, that is remove the columns. I don't want these columns like total senior citizen. I don't want. I just want 2020, this much portion. It's like a fraction. Fraction in the sense, you understand, it cannot go below 0. It cannot be more than 1. Okay, any number between 0 to 1 should come. How do you get that? Senior citizen divided by the total, right? What portion of the whole population is senior citizen? I want you to display. Okay, yeah. So you have say 2 minutes of time to do that, and please put your answers in the chat and give me the answer directly. Okay, don't show your answers to others. I want you to share the answer only with me in the chat box. Okay, yeah, please go ahead. So we know something about the Pandas series, right? Because we are operating between the series now. Though the data is represented in the form of what is called as the data frame, you can see that what we want is we want to operate between the two different Pandas series. So in a data frame, how do you access the series? It's by the column name, right? So what was my question? I want you to calculate, say something like a fraction. Okay, so let me call it like this. So fraction, I'll call SC for senior citizens. Okay, so that means this is equal to so population data frame, right? In that data frame, that's what you see as an output of line number 15, right? In that line, what you are supposed to access, which one should be the numerator? That means the whole column called senior citizen should be the numerator. So how do you access that? Simply tell the name, that is SR dot, right, senior citizen. So this is going to be the numerator of that. Okay, divide that by population data frame. In that, what is the denominator? Every entry of the total. Okay, so this is what is your fraction. Now, let's look at the fraction. Right. So I told, right, you don't have to get an answer for me in the form of what you call in any of the specific format. I don't have any restriction, right? If few of you have tried, yes, okay, I appreciate that. Right. So let's proceed further. Now, how do you convert this to the data frame? This is the next quiz question. Okay, please type your answer over there. Now you see I have a series. What series is this? This is the series corresponding to multi-index, right? I have multiple index. So my series is only the last column, 0.10, 0.092, 0.076, 0.094, 0.063, 0.092. That's my data, which is present in the form of a series. How do you convert this into a data frame is my question, right? Already we have used two functions. One of them you are supposed to use. That's a hint. Okay, quickly type your answer. Okay, and we'll see that. So just now we discussed two different functions, right? So I actually have done this just now. This is just an exercise for me. Please go ahead. All right, so I want to convert this multi-indexed series into a data frame. Simply use that variable dot unstack. All right, so that's the answer. Yes, we have few right answers given. I appreciate your efforts. Let's go ahead. Next thing is that now we understood the concept of what is multi-index and one of the method to create that. Now, what are the other methods that are available so that we can create multi-index is our next concept. Okay, so let's quickly look at that. So let me try to create my data frame. This is equal to PD dot. If you remember earlier, I created actually a series, and from the series, I converted that into the data frame. Now I'm telling you that how one can directly create the data frame. Okay, multi-indexed data frame. So this is all. This is the method. So pt.data frame. First, let me inform the machine that this is what I want to create. So first, I'll tell you this is my data. So since I don't have, okay, this is a problem for us because I did not import NumPy. I'll do that now. Okay. Import NumPy as NP. Fine. So now I'll use the NumPy over here. That is NP dot random dot rand. Let me see 6, 4, 6 rows and 4 columns. This is my this is the data. Then I have to tell what is my index and what are my columns. Index in the sense horizontally, column means name of the columns. All right. So let me try to type the indices first. Index equal to, since you want multi-index, right? So you see the example in this. So there are 3 main indices like Bengaluru, Mangaluru, Udupi. Inside each of them, we have two sets, correct? So now, while entering, whichever rows are corresponding to Bengaluru, I should specify Bengaluru so many times. If you want for 2 different rows, 2020, 2010, you want Bengaluru as the main, what you call index means Bengaluru should come both of them when you enter directly in the form of a data frame. Okay, so I'll just explain that once again once we finish this. So I'll go to the index. Let me say that I have, this is my main index, let me see. Okay, I'll say AA. So let me say that for 3 different rows, I want AA as the main index. So what I'm trying to do now, I'll write the same thing again and again. AA, once again. Okay, then AA. So this means, right, for the first 3 rows of my actual data, AA is the something like a key, right, is the main key. Then I'll write a secondary key at a later stage. Okay, so that's why it is AA. Let me try to write another one, that is BB. Okay, so next 3 rows will be indexed by BB itself. That's why I'm writing BB, comma, say AB. All right, so after this, so 6 lines are over. you see why I wrote 6? Because np.random.rand creates 6 rows, 4 columns. So row wise, I should have 6. All right. So that's the first thing, right? This is my one of the index. That's all. Because you see, I actually have opened 2 square brackets over here. The first bracket is the main bracket. Inside that, I should write all the indices. So after that, I wrote one more square bracket. I wrote the main index values over there. That is done now. So after that, I'll write what are my sub indices. That means, right, like this. So let me try to write in this way. Let me give numbers over here. 1, 1, 2, 2, 3, 3, 1, 1, 2, 2, 3. So this means I try to cover up, right, the sub-indices as well. So AA, my first thing. So after that, I'll write 1, 1, 2, 2, 3, 3. Then it comes BB. Again in BB, 1, 1, 2, 2, 3, 3. This is what I wanted to do. So that's why I entered in this way. Okay, so that is done. Now I am supposed to write the next part that corresponds to what we call as the columns. What are the various columns you want? How many columns are they expected? There are 4 columns expected because 6, 4 is my size. My matrix, what I am asking machine to generate is 6 rows, 4 columns. So 4 columns are going to come. Let me try to give a name. This is first, then second. Okay, you give any name, doesn't matter. Okay, third, and the fourth one. Okay, so this actually creates my data frame. Let me try to run this part of the code and let me check whether I have any error. Okay, I'm trying to check this. Okay, as of now, I don't see any error, right? So let me try to do something like this. Let me try to visualize that first. Okay, before I proceed further, I just want to see. My dear, yeah. So this is what I was expecting. I hope it is clear now. So what was the intention behind writing the code like that, right? So before I show this output, maybe there was some confusion among yours, but now it should be clear, right? What I have done. So I directly created a data frame with the multiple indices present over there, right? So this is one way, and let us try to do another way, right? This is like I pass a tuple. I converted a tuple into series, Pandas series, and I passed the series. I converted the series into a data frame. This is what was my approach when I was dealing with the conversion of or obtaining a multi-indexed data frame, right? This was my approach. Now I'll show you the direct method, right? So I'm not going to do all these. So initially you see today, we converted, we created the indices, then created the series, converted the series into the data frame, right? So it was a 3-step process, but you don't have to go through all of them. Directly you can convert, right? The same thing I'm trying to write once again. So I'll call it as my data that is equal to, let's try to convert it this way, right? So I'll try to see the approach is this. I know that I'm passing a dictionary, right? We created a dictionary earlier. I have to create the dictionary because there is no escape from that. But whenever you create the dictionary, keep your tuples as the keys, right? What happens? Pandas is so capable that it will automatically identify that, okay, so whoever is entering this, his intention is to create a multiple indices, create multi-indexing is the idea of this user. It automatically identifies. Okay, so that automatically it will convert whatever you have entered directly, it will be converting that into the required format. Okay, so that's the one fundamental idea over here. Right. So that's my index now. So let me try to create the that concept now. So let me try to write this. So I'll start with the first key, right? The first key, if you remember, we had entered All right, that's the key, followed by the year. I'll write. So you see, this is my tuple. I'm using the tuple as a key. So after that, I'll write some number, say, I think, all right. So like this, I'm supposed to enter. Okay, I'll just do for one or two so that we'll not waste much time over here. Okay, so then we'll be writing once again. Sorry, I think I made a mistake here. It's not this, it has to be comma. Okay, so then you write 2010. Enter the next set of numbers, whichever you want to enter. All right, so all right, so that actually is your next set. Then let's go to next key, right? You will always use a tuple as a key. Okay, go to the next city, maybe. So I'll make this as a key and then I'll enter a number. Enter another one. Now you see, since you are entering Bengaluru year, Bengaluru another year, Mangaluru year, Mangaluru different year, it actually identifies that okay, this person is wants to create the multi indexing. All right, so let's visualize that now itself. Okay, so that has been created. Now go to series is equal to pd dot series of, right, my data. All right. Population series, you can see it actually converts. All right. Then let me show you another method. So previously we saw that from tuple, how do you convert, right? So there are other options also. When I tap that, when I type the tab over there, you saw many options here, right? Out of that, one of the option was from arrays. If you have array, how do you convert from an array to, right, multiple index? How can you convert? That is the next part of the question. Okay, so let's try to answer that. So directly I can use pd dot. I'm saying that create me a multi-index. I just have to say from where. So it says from arrays, from pair, from frame, from product, from tuple. I'll show you from arrays. So that means I'm supposed to enter two arrays. So the arrays will be present inside the square braces. So the first one is say AA. So this is the same thing which I did earlier, but using a different approach. That's all. Oh, okay, let me go for BB itself. Okay, then I will write the numbers over here. All right, so 6 lines are there. Okay, fine. Let's look at that. You see the answers are created in the same way, right? So it actually creates a multi-index, and we are able to see that, right? The multi-index have been created, indices have been created for AA 1 1 2 2 3 3, and the BB also 1 1 2 2 3, right? So that's the way. So if you want to enter, this is one option. The other option is already we have checked that, right? That is using the tuple, right? So you can simply create the tuple saying that AA 111, once again AA 222, AA 333. Then you go for other one saying that BB 111. Inside the normal parentheses you enter them in the form of tuple, it will be created. Already we have done that. So right, you can see that technique right earlier, which we have. You see, simple, these are the tuples. So my index is actually a tuple. You see, like Bengaluru 2020. Similarly, I can just do that. Yeah. 111, AAA, next number, AAA 222, BBB 111, BBB 222, like that. You can keep entering in that way. So that is another method, right, which uses tuples to do the same job. Okay, let's go to the next one. There is another option, that is PD dot the multi-index dot from. I'll show you the interesting one. This is a product. You don't have to do much of the typing work over here. This actually saves a lot of time, right? Like this. AAA and BBB. These are the two main indices. Okay. And after that, I'll write what are my sub-index values corresponding to each of them. So I'll simply write this has to be 111. That's all. Okay. I close this. Enter. You see, it created the same thing. So the from product is the widely used technique. Okay, so any doubt you have, please go ahead. Right. The next technique that I'm going to discuss now is, right, I can try to create, right, something from what already that exists. All right, so I can actually try to give, say, the various names to these levels. What I mean by level names, I'll try to write it in this way. Okay, I think I already have something called as population series. Let me try to visualize that. Yeah, I have something like this. Okay, so what I try to do now in the population series, I'm trying to specify that give me an index. Okay, so index. So what are the indices? Bengaluru is the main. Bengaluru, Mangaluru are the main indices. And 2020, 2010, 2020, 2010 are the years. Now I want to, because if you are showing this to someone, they might not understand what is your intention behind showing this. So what I try to do now is I'll try to enter some values. Like I want to say that what are those indices? Index dot, say that they are the names, equal to, just tell what you are trying to enter over there. So maybe city, and the second one corresponds to year. Just see that. Okay, now it actually changed my population series, but I didn't ask it to show me that. So let's see population series. So now you see this, see the difference. So above Bengaluru and 2020, this line, we don't have anything, but here it actually adds a line containing city and year. So what is what, right, can be explained even for a series in this particular fashion. All right. Now, this whole concept, what we have discussed so far, is talking about the multi-indexing only for the rows, right? So, but by obvious means, it is necessary that you will perform the multi-indexing even for columns. So for column data also, it is always expected that I should have something called as multiple indices or multi-indexing. Let's see how to do that. I'll try to write a few lines of codes here, because without that, we will not be able to do that. Okay, so this is, okay, let me try to create the index first. So index is equal to, I'm creating a multi-index for rows, PD dot, this is multi-index dot from, I'll use the product because as I already mentioned, it's the easiest one to create if you know, right, what you are trying to write. So let me say I have 2021, 2022, comma. I'll also write 1, 2, 3. Okay, so then I'll write names. This is another method of entering names. Previously you saw how to enter the names. Now I'm entering the names in a different way. So this is year. The first one corresponds to year, and the second one is visit. So now you understand that what I'm trying to create at the end. All right. So let's say this is what is my index. Let me write index. Then I'll go for columns. Okay, columns is equal to PD. Again, you can use multi-index even for columns. PD dot, this is multi-index dot from product. Now I'll try to enter the names of, some names will come here, right? Say this is something like, let me tell you what I'm trying to create. I'm trying to create a patient data set, right? Patient data set, 21, 22 are the row-wise index values. So in 2021, there were 3 visits: visit number 1, visit number 2, visit number 3. So similarly, the patient visits a hospital even in 2022, 1, 2, 3, 3 visits per year. So that's what row-wise I'm talking about. Now I'm talking about the columns. So when I go from a column-wise, I have to talk about each of my patients. Let's see. So I'm trying to enter the patient's value names now. Okay, so the first one, let me try to write. All right, so the first name, the second name, okay, then the third name, okay, and let's also go to the fourth name here. Okay, so these are the 4 names. Then I'll go ahead with the, let's say each time a patient visits, right? For each of the visit, say 3 different parameters are collected from the patient by doing some tests. Let us say this is what we are trying to capture from each of the patient. So the first one is HR, standing for the heart rate. Okay, this will be collected. Then say temp, meaning temperature. Okay, then you also measure the blood pressure. Okay, I think that should be pretty clear by this time, right? So after this, I'll also specify that what are the names to be given. Okay, so names is equal to, so the first, the main column names are the patient names. So you can call as patients, all right? Patient, and the second level. So main, I get patient name, and second one is what are the various measurements that you are taking for them, right? So I'll just try to write readings. Okay, let me see whether I get any error. No, it says that no error as of now. Let me try to create a data for the family. Data is equal to np dot, there is a function called round. I'm trying to convert into a round. Say np dot random dot rand. So you see there are 4 patients. Each patient has 3 readings. So 3 into 4, 12 columns. How many rows? Right? 2021, 3 visits. So 3 rows. 2022, 3 more rows. So totally 6 rows. 6 comma 12. Right? This is what is the size of the data that I'm expecting. Okay. np.random.rand. I'll write 6 rows, 12 columns, and I'll just say that maximum value is 1. Okay, so this is, say that this is the data, and because this numbers always come between 0 to 1, right? So I don't want that to be retained. I'll try to make it a larger number. So data of all the rows, everything with a step of t, right? I'll try to do a manipulation here. Okay, so this is just a manipulation, an optional thing for you. Multiply that equal to, say, I'll do 65. Okay, so this is what is my step, so that I can convert the numbers into a larger ones. Okay, so that's one thing. Then data plus equal to, every data I'll add 30 to that. This is the data. Now you see I'm converting. Patient data is equal to PD dot data frame. What is your data? It's in the name data itself. Data comma index equal to, what is the name given to index? It's INDEX. See, line number 30 I'm referring to. Line number 30 has indices present. So index equal to that index. And columns. So columns should be equal to, what's the name given to the columns? Line number 31. So just refer to that. Line number 31 says columns itself is the variable name. Columns. Okay, so that creates a patient data. Now I'll show you. Now I'm able to show you what I try to create. So patient data is this. See, I have 2021, 2022. In each of, that's year. Above that, I have written that it's year. And visit number 123, 123. So in each year, a patient visits 3 times. Then topmost row is patient. In the sense, patient names come there. So Sundar, Kumar, Nandini, Kaveri, whatever we entered, it's coming there. Then below that, we have readings. What are the readings for each of the patient? It's like HR, heart rate, temperature, BP. Again, for Kumar, heart rate, temperature, this thing. And so on, same thing completes, right? Same thing continues over there. So this is how you are able to create multi-indexed data frames, and the multi-indexing is being applied for rows as well as columns. All right, very important concept, right? And I want you to practice this with your own data. Right? Just once you get this particular file, right? I want you to understand this and try to create something which comes into your mind. Try to create a data, right? Like this. So only to get these larger numbers, right, over here, I try to do these 2 steps. 33, 34 are optional. If you don't use that, it will simply come like 0.01, 0.05, something will come that may not look pretty much what you call convincing values for heart rate, temperature, or something. So simply, right, convert it in that way, right? Apply your own logic to get this. Now, how to access the data from this? I have a multi-index. Do I need to mention all the indices so that I can visualize something? So this is how. It's a patient data. Just to tell the column name, main column name to visualize a particular patient's data. For example, I'll just write. Right? So that's how you get the information corresponding to one particular patient. Right? So I want you to work and spend more time on this, right? Because that is very important. As of now, I may not be able to spend much time over here because many things are there to cover for us. So then the next concept, I'll directly move into the slicing and indexing of a multiple index case. So let's first look at the population series. Whatever we have created, this is already there, right? Now you see, I can index by using this. So the population series, let me say, I want to look at this city and I'll specify which year I want to see. 2020, right? So you can see that I'm able to visualize this, sorry, not that, the one below that. Directly, I can see that. So you just have to, first you need to enter. So normal procedure, but you will enter the name of the city first because that's the main index. Then the sub index will be coming after the comma. So any number of any layers you have, right? Main, sub, and secondary sub, etc. If you have that, you can keep entering in the same way so that you can access that. Okay, very straightforward this thing. So you can also do something called as a the partial, right, slicing, like from here to here you can actually enter that, right? Something like the population series. This is another method to access that. I'll just sell all the rows of 201. Okay, that's another method, right? Then I can actually specify the population series of greater than okay, let's see. Yes, right, you can see that this is also possible, right? You can apply some conditions and extract the data from that's an indexing by using, right, the conditions. So and or etc are also possible, right? I want you to try. Okay, so that's what is important. And then we'll move for multiple indexed data frames. For example, we have the patient data with us. I'll just show you something with the help of that. So in this particular data, in the patient data, I am asking to see the Sundar and just show me the temperature. See, you are able to access that. So even for columns, this is applicable. I just want you to see that. Then we have seen that you can access the various entries of a data frame by using ilog and log, right? So I'll try to show you that as right. So the patient data dot, if you know the index location, this is a better option. So you just have to say that, right? :2, comma, :2. Let's see, right? 2 rows, 2 columns. Just show me that. This is the option. And if you don't want to go with this method, like indexing, you don't want, like 0, 1, 2, you don't want, like you know the name of the columns specifically, then this is more preferred. So patient data dot use LOC, location. I'm talking in terms of the location, right? So get me all the rows corresponding to, I'm talking about columns, and I know the column names, what I'm looking for. For example, I think there is a patient by the name, yeah, we have. Then let me say that I don't want to look everything corresponding to Nandini. I just want to say the people. Okay, see that particular name and one particular parameter out of that, right, has been provided as an answer because I asked for that. Okay, right? So that's a better way. Then what if you want to look at the temperature of every candidate only in the second or a specific visit, right? For example, this is my question. What are the temperature readings of all the patients in their second visits of every year? 2021 second visit, what are the temperatures? 2022 second visit only, I'm looking for what are the temperatures. So if you want to do that, you have to perform what is called as the index slicing, right? So this is the method to perform index slicing. Simply create an index that is equal to, you can call it as PD dot index, yeah, index slice. You can see that. That's what is called as index slice. Okay, so do that and then go to the data. Okay, so there is a patient data dot. I'm going to look for the specific locations now. So use LOC, right? Inside the LOC, right? I have to talk about IDX because IDX holds the sliced indexes, right? Indices. So IDX, I just have to say that among the IDX, show me everything for the value equal to 2. Then once again, IDX of everything corresponding to, I think I need 10. Yeah, so you see, right? This this is corresponding to second. So second, in a sense, row wise, I'm talking about every row, show me only the second option, right? Doesn't matter whether it is 2021, 22, doesn't matter. So you don't have to mention that at all. Simply say that visit equal to 2. So that's what I'm saying. Index, this actually corresponds to the years. I'm not worried about that. So I just have to look at this 2 in each of the case. Next, indices, right? You see, this actually corresponds to the second index which you write. So inside the LOC, I have to write 2 values. The first value is corresponding to the row wise. I specified that, go for 2. I just want look at the option 2, not others. So second value inside the LOC is corresponding to column. So the second IDX, what you have written here, corresponds to column. I'm just saying that I don't worry about which patient it is, just show me the temperatures. For every patient, show me the temperature. So that's why you are getting this as the answer. All right, so that's the concept which we call it as a multi-indexing. Okay, all right, then, okay, let me show you another very interesting option, right? I have already defined the population series. Let me bring it back again. Now, in this case, I can try to perform what is called as a unstacking at different levels, right? In the sense, it is possible to convert a data set like this into multi-index, like a 2D representation or a simple case by just mentioning what level of unstacking you want, right? What I mean, I'll show you now so that you understand. Okay, so this is what is the first thing. Population series, I'll say dot unstack. This is fine. We have done that. I know that this is going to be converted into a data frame. But now I have an option saying that what is my level? So if you say level equal to 0, this is what happens. Okay, so you see here, level is equal to 0 means only these two, the cities are moved. Okay, the cities are moved to the top and years are kept as it is. So level 0 means this one. I have another option. Okay, so population series dot unstack, and let's do level equal to 1. See the difference, right? Level equal to 1 in a sense. So 0 means the first one, right? First column of your representation, that is actually corresponding to the cities. Cities are moved. When I say level equal to 1, so the next level will be moved to the top. Next level means what? It is year. Years will be moved to the top. Saying that 2010, 2020. So cities are kept as is. So this is the unstack. Okay. So that's about what you call as the stacking, and also the unstacking can also be extracted in the same fashion. Okay, all right, then let me try to show you how do we do some of the modifications. All right, let me come back to our patient data once again. Patient data. So in the patient data, I'll try to do something called as aggregation, right? Aggregation refers to you can perform the mean, sum, max, etc. You can directly apply at different levels, because now you see that the data set is arranged in different levels, right? You have various years present, various visits along the rows, column wise a patient corresponding to a patient, what is the heartbeat, what is the temperature, what is the BP, it is repeated at different. So we can try to apply the aggregations at different levels. Okay, so how do you do that? I'll show you this. So this is what I want you to apply. So I'll call it as a patient mean. This is equal to the patient data dot mean. This applies mean to everything. I don't want that. I want to say that apply this at a level equal to year-wise, I want the mean. Okay, so the patient mean is what I want to see now. See, every year, all the 3 visits, it is taking the mean value and it is displaying over here. So columns do not change. All columns are still there. But what is the heart rate of a patient in 2021? During all the 3 visits, it take a mean and puts a value there. Like that. So you can specify what level you want to, right, perform. Okay. Now I'll show you something else, right? I can even mention this by specifying the level, right? Which level you want to do this, I can actually do that. So level 0 in my patient, this thing, level 0 means year. Level 1 means what? It is a visit. Visit 1, visit 2, visit 3, right? So if you want to do the aggregation over there, I'll show you how to do that. Okay. So patient data dot, let me say I want to take a mean, but I want to make a group first. So there is an option called group by specify level equal to 1. In the sense, in both the years, 1 means first visit. Both years, what happened in the first year, you group. And then you take the mean. Okay, so you see here. Now the years are not there, right? I'm clubbing visit number 1 in every year. I'm clubbing them and then taking the mean. So that happens to be, right, like this. This is the mean of first visit in each year. Doesn't matter which year it is. So the next one is second visit in each of the year, each year, the third, etc. So how did I specify I want to do this? I said that group the data in the whole table, you make groups according to level equal to 1. Level equal to 1 means not the first column, the second column. So in my specification, the second column actually represented visit. The first column, which is a 0th column, that actually talked about the years. So years are not being considered. I'm just doing like this. Okay, I'll show you the same thing applicable to that itself. So the patient data dot, I'll say group by apply the level equal to 0 now. That means year wise I should see something. I'm not worried about whether it is first visit, second or third visit. All the 3 visits will be clubbed together. And I already have applied the mean. So let me go for, let me check median. Yeah, you have median. Okay, so 2021, this is the median value. 2022, this is the median value. Very simple, easy, right? Just understand what is the way in which you are supposed to enter the instruction so that, right, the pandas understands that. Now, okay, column wise, let's do that same thing in column this thing. Okay, let's say already we have a mean with us, right? That's a patient mean, right? So I'm going to apply. Now you see this patient mean, actually already I have applied the aggregation row wise. Now I can directly apply column wise. Okay, so that means I think we have a patient mean available with us, right? Patient mean dot, it's already mean. I'm trying to take a mean of that now, but in a different way. I'll say that axis equal to 1. In the sense, look, like this, you take the mean. So I'll specify mean axis equal to 1. Okay, and I'll also tell that show me the answers. Like, so what happened to the heart rate? What happened to the temperature? What happened to the BP? Right? Average of everything I want. So it's row wise. So 2021, I want 1 answer for heart rate, 1 answer for temperature, 1 answer for BP. That's the average of every patient. So 1 means when I write axis equal to 1, I know that I'm going to look horizontally, right? That means column wise, I'm trying to consider something. Axis equal to 1. So level is equal to, tell the level, what level you want. It means I'm supposed to look for the readings, right? So reading wise, I want to make a group. Heart rate of Sundar, heart rate of Kumar, heart rate of Nandini, heart rate of Kaveri, take average, give that as a single column. Next, temperature of Sundar, temperature of Kumar, temperature of Nandini, temperature of Kaveri. One, take a mean, give a value, and so on. This is what I want. So level should be equal to, I think it's a reading. No. All right, let's see. Yeah. It throws some warnings for us because mostly in the upcoming versions of the pandas, they're going to remove this method. Okay, whatever comes there, we'll study at that time. Don't worry about now. So directly, right, you can use it. This is what I want. All right. Okay, then let's move further. Now we shall discuss about how do you club the various data types, because this is very important. Now let us say you divide, there is a team which is performing a particular project. So, your intention is to do a research work. So you split your team into two parts. One team goes to location A, another team goes to location B to collect the data, right? So team A collects, say, 10,000 rows, so many columns of data. Team B also collects, say, 20,000 rows, same number of columns of data. Now, in order to perform the experiment, you need to club the data together, right? So how do you perform the combination? How do you get the combination of that data set is very important. So that's the next concept that we are going to discuss now. Okay, so let's quickly go through that. That's pretty important. So this is how you do that. Let's try to create two series now. Okay, my series 1 is equal to pd dot series. Okay, let me write A ABCC. All right, this is the data. Let's say comma index equal to, it corresponds to the series, right? So I have to specify index, otherwise it will put 0, 1, 2 by default. Okay, so this is my series 1, and I'll also create a my series 2 that is again equal to pd dot series. Let me create the next few values like dd comma ff. All right. Okay. Let me add something more. Let's say somebody collected more data, somebody collected less data. So A, B, B, C, C are collected by one team. Say D, D, E, F, F, G, G collected by other team. All right. So again, I'll try to add an index to this equal to enter 4, 4, 5, 5, 6, 6, 7, 7. All right. So that's actually the second data frame. So two of them have been created now. Now I want to club. So after you come back and meet, you have to club them together. So how do you do that? One of the method is called as a concatenation. So pd dot concat is the function. So just you need to tell, right? These are the two data which I want to club, right? Write it inside a list, right? Like a square bracket. It's not a list, inside a square bracket. So this is my series 1, comma my series 2. So you can see that, yes, they have been clubbed together to get something like this. Okay, but I'll tell you a different approach using which you can even convert your data into the required format. Okay, so for that reason, I'll try to go ahead with something called as what happens if you have if you have, say, duplicate indices. Okay, so duplicate index means, let's try to do it in this way. So let's try to write a function here, right? So recall, how do you write a function? Define and write make df, make the data frame, right? So in order to do this, I'll pass column name, I'll pass index value. Okay, this is what I'm trying to pass. So once we pass this, my data is equal to, see, I'm trying to use use dictionary comprehensions. Okay, so we had discussed various comprehension techniques, right? One of them is dictionary comprehensions. Just see how I'm using it. So C colon, I'll just try to write str of C plus str of I, right? What is C and I? It's yet to come. Okay, so for C, strc plus stri for I in, I think we called IDX val. Okay, this is what's inside the square brackets. For C in column name. Okay, so this is what creates the required data. So once I have the data available with me, immediately in the next step, I'll try to return pd dot data frame, the data, my data, comma, the index values. So I just have to return this. So I'll show you how this works, right? Let me run this. Okay, this runs fine. So I'll call this function. What was the name? Make df, pass the column names, right? So you see the first thing you are supposed to pass is column name. I'll just write A, B, C, D, E, F. And what are the index values I'm supposed to write? It's a range 1:5. Just see. Right? So it directly created something and it's actually providing you an output. Okay, so make df, I'll just try to run this once again. Make so 4, 1, 2, 3, 4, that's what was expected. So it actually created something and it tried to return. My mistake. Sorry. That's why it was giving a wrong answer. Now you see this is the right answer. Okay. So my data should be a small letter because I'm creating a my data here. So I'm trying to return the my data and index value. Right. So C and strc plus str of I. Str of C means A, I means 1. A1, B1, C1, D1, etc. It's automatically, some randomly, I try to write something over here so that it can generate what I request. Right. So I'm saying that A will be 1, 2, 3, 4. Right. So that is the first column. Then B 1, 2, 3, 4. Second column. C 1, 2, 3, 4. Like that. Whatever we are asking, same thing it is trying to generate. Now, let's try to do 2 data frames out of it. Okay, my df1 is equal to, I'll call the same function, make the df and pass a ABC to that. And I'll say that 1, 1, 2. Okay, this is my df1. My df2, let me try to create. This is also make df. I'll say ABC itself, and I'm asking say 3, 3, 4, 4. All right. So let me try to print my df1, my df2. Oh, so if I try to write that, it's not printing in the way I expect. So let me try to use this. Okay, so this is what I'm expecting. I'll also type So print my df2. Okay, so this is what has been created so far. Now I'll try to do a concatenation, right? So this is another example of how to perform the concatenation of the data frame. Previously, we looked at the concatenation of two different series, right? You collected your teams, two teams collected data in the form of a series. You concatenate using pd.concat of series. Now you collected the data in the form of data frame, right? So two tables you have. How do you club that? It's once again the same thing. So that is pd.concat. Just specify my df1, comma, my df2. Okay, so they have been clubbed together in this group. All right, so you can also do a concatenation row-wise. You don't have to go with the column-wise. You can simply go with the row-wise in this way. Okay, so let's try to do this way. My df3 is equal to, let me use the same function to create that. Make df, pass it on the column values like df, dh, and tell that the row indices are 55, 66. Okay, so this is the df3. My df4, I call it as make df. I'll call the different names for the columns. Df, dh, ijk. Okay, 55, 66. Okay, so df have been printed. My df3 is this. My df4 is this. Okay, I'm trying to do the concatenation one after the other. In a sense, I am supposed to add a new column. All right, so you are doing it row wise. Every row you are doing something. You are adding a column to that, in other words. So pd.concat, just to specify, right, what you want to do, right? Which are the two data frames that you want to concatenate. So that will be, what was the name? Sorry, my mistake. My df3 followed by my df4. If I don't specify anything, it will be one below the other, but I want to say that axis equal to 1. So you're adding a column, right? So first you have this, next comes here, right? So row wise you are doing the attachment, right? So that means we have what is called as the concatenation that are actually possible in this particular fashion. Okay. All right, then let me check what else we can do here. Okay, right. I have my df1, my df2. I'll bring them back once again so that I can show you something more. My df1 is this. My df2 is this. You observe that the indices are different. In the sense, for the first, that is my df1, in the index value 11 and 22. For the second, my df2, it is 33 and 44. So can I make sure that the index of one, so both of them have the same indices? Is it possible? Yes, it is possible. My df2 dot index equal to, you can assign something like this. My df1 dot index. Okay, now you see what happens to my df2. See, my df2 in line number 77, you can see the result as having the index values 33, 44. Now they have been changed to 11 and 22 because you did something like this. Now, if at all you try to do the concatenation, what happens? pd.concat, I'll try to call their names. My df1, comma, my my df2, what is the result? You can observe that the indices are repeated, but we know that we want the index values to be right, pretty much same for all of us. So in order to do that, we can use something called as ignore index. Okay, so pd dot concat, I'll just specify my df1, my df2, right? I just want to do the concatenation of this. Then I'll say that ignore index equal to 2. See the indices now. So when you concatenated earlier, the indices are same, 1 1 2 2 1 1 2 2 repeating. So after doing the concatenation, sorry, after doing a concatenation, the 0th value of one of your data is unique. Next data, there cannot be another 0th value, correct? So that means 11 should not repeat, 22 should not repeat. But unless and until you specify that, right, make changes like this, Pandas will not do that. Okay, so this is another option. Like some of you collected 100 data set, some others collected 80 data sets. So total you have 180, right? So you want to start from 0 and go till 179, not like 0 to 100 and again starting from 0 to something. That makes no sense. So this is one way of doing that. Okay, so this is one thing. Then, okay, after collection of data set in this particular fashion, now how do you, let's say you want to have a separation. Have a separation in the sense, okay, first team, these are the 100 data you collected. Team number 2, this is the 100 data you collected. If you want to keep that kind of tracking available, then yes, you have an option. Okay, so let me try to show you the my df once again. So my df1, this is the original one. My df2, this is the data set collected by others. Okay, when I club them as it is, you know that what happens, right? Their index values will be retained, but 11 repeating once again 11 means makes no sense. So if you still want to keep that format, you can have you can mention that, okay, you can add a you can bring the multi-index concepts over there, saying that these are my keys, right? How to do that? I'll show you now. So pd dot, this is concat. Just specify what you want to concat. My df1, my df2. All right, my df1, my df2 is done. Then specify key. Okay, I think it's keys. Yeah, key is equal to. So the first set which repeats, like 11, 22 repeats, right? You can call it as, say, the first data set you have collected. Then once again, see that the team number 2. The second team collected this, I can actually specify. Okay, see this? So first 11, 22, like 0, 1, 2, 3, 4, so many data you are collecting. That's team number 1. Then the second team collects a different location, different value. Their values will also start from 0, 1, 2, 3, dot, dot, dot. So if I keep them as it is, there is no sense for that. That doesn't make any sense because 0 can, one index value occurs only once. Now you see you added a column name to that, sorry, row name to that, saying first this set, second this set. All right, so that's it. That's a very useful concept. Okay, I wanted to practice this more because you will end up using this kind of representation, right? Regularly, whenever you are dealing with various kinds of data sets for your projects. Okay, so that's why I'm stressing this out. Okay, then let's try to see what we have in my df3. Okay, my df3, I think I have something like this, and my df4, yeah, I have something like this. Okay, now okay, there are nothing common present in that. What happens if you try to club them? Okay, is my question. So let me try to do pd dot, will it throw an error because column names are not same, row names are same. So what happens if I try to do a concat is what I'm trying to explore now. Okay, my df3, my df4. Okay, very interesting. So 5566, it's expected because by default, it is going to do a concatenation one below the other. Okay, that means you are trying to have the row ones, right? One below the other will be the case. That's what has happened here. That's clear for me. But since the column names are not same for both the data frame, it still keeps the column names as is. DFGH for the first one, and corresponding to DFGH, you can see that the second data set has not a number. Okay, very similarly, the second data, that is data frame 4, has these values corresponding to IJK, but my first data frame has no IJK, so it automatically adds not a numbers over there. Okay, so this is one very interesting concept. All right, now let me try to make a small modification. Okay, let's try to go. Let me try to go back and check the my data frame. Okay, I'll copy that, but I'll paste it in a slightly different fashion here. So data frame has df ghij. Okay, so I also add, say, something like ghij for data frame 4, and I'll call this function again. Okay, before that, let me visualize my df4. Now you see my df4 is this, and I will call this one. Now you see, whatever is common, you have something, right? So G and H are common between both of them. So, okay, I'll show you even the my df3. So you see my df3 and my 89 and 91. What are common columns? G and H. So you look at number 90, G and H have all the 4 rows present, right? But DF does not have the second set, as well as the IJ is not there in the first set, because of which I have this answers coming. Now, what if you want to have only those columns which are common? Can I get only that? Because G and H have something common in both of them, others are not. So you can call them by doing in a set operation. It is called as intersection. Intersection means what is common in both of them, right? So intersection can be sorry. Intersection can be obtained by doing this pd.concat, tell this, and you have to specify the join equal to, specify that inner. Inner in the sense it's actually the keyword which is used for performing the intersection. Okay, if you want to perform what is called as the union, not the intersection, then by default you can see that this is what is the union. By default, it will do the union, but if you want the intersection, you have to specify join equal to inner. So this is called as an inner join. Okay. Right. Let's also look at the IDF1 once, IDF2 also again. Now let me show you something. Let me try to append. There is an option called performing what is called as append. My df1 dot append bracket my df2. Right? Append is also going to do the same job which we have done earlier. Okay, so that's the second concept, right? That we were supposed to discuss further. Let's move further. Then there is an option called combining of the data set by using a merge option. So merge is another function right, that we can use to, merge the different data sets that are available. Normally, various tables you have, corresponding to a company data set, you may have different tables. How do you merge them is the question. Okay, so merging is actually very important. All right, so this is an example. I'll try to go to my df1 is equal to pd dot data frame. I'll try to create a dictionary. The employee is a key, and I'll enter the names of various employees who work over here. Okay, employees. Okay. All right. Okay, that's the third employee. And the fourth employee is fantastic. Okay, so this is employee. Then I want to add which division. They are working in which division. Account section. Somebody is working in account section. Somebody is working in R&D, research and development. Okay, the candidate number 3 is also working in R&D. Okay, and the fourth candidate is working in human resources. Okay. So let us visualize this data. Okay, that is my df1. Right. Also, let me try to create a different data frame. My df2 is equal to pd dot. It's a data frame, right? I'll try to create another list here. Okay, sorry, another dictionary over here. That is employee. Maybe it is present in a different different data frame. Doesn't matter. Consider this to be a different what you call a different table that is that has been maintained in the in the computer of my company. Okay, so employee. I'll try to. You see the different order. I'll try to enter. Okay, this is the first employee. Employee number 2. Okay, then employee number 3 is okay. Again, somebody else created this particular table. They have entered it in a completely different format. Okay. And the second thing is the date of join. Okay, which date they joined my company. Right. So 2021, 2020, 2019, 2022. My DF2. Right? See the order in which both tables have been created, they're completely different. Now you see, right? I'll call what is called as a merge. Okay, my df3 is equal to pd dot. There is what is called as a merge option. Pd dot merge my df1 comma my df2. Okay. Check out what is my df3. Okay, so though the order in which the employee names have been entered in both the tables are completely different, the Pandas understands that. Okay, Pandas understands that, okay, this is how it has to be done. Right? So that's the first thing. Another very wonderful thing about Pandas is something like this. Let me create a my df4. So that is equal to pd dot data frame. Let me create another data frame, right? I think we have a division already existing. divi, it's a division, right? I want to enter the divisions in the same fashion. There are 3 divisions in my company, let's say. Okay, the first one is, I think, accounts. All right, I'll enter the same thing. Then we have the second one that is I'll enter in a different fashion. So HR. And the third division is R&D. Okay, so these are the 3 things, and I'll try to enter a different one now. So that is called as funds. So to each of them, how much funding per year? Maybe this is what I want to enter. Okay. All right. So this is the fund that is available for each of them. My DFO. Okay. Now you see, I try to merge the data frame 3 with this. All right. So let me try to do that. My EF5 is equal to PD dot merge. I'm trying to merge what are the things I'm trying to merge. That is my DF3 with my DF4. Okay, inspect my DF5. Just look at this, everything is visible to you, right? Line number 101 is data frame 3. 103 is data frame 4. Now I'm actually clubbing, I'm trying to merge them by the divisions, right? Whoever is the employee, whichever is the division, according to that, the funds have been added, right? So Bharat works in account division. So from my data frame 4, you can understand that accounts gets a fund of 2, 3, 4, 5, 6. So that actually comes in front of Bharat. So Chandra and Dhaarini working in R&D. So from data frame 4, R&D gets 98765. That's the amount. So both of them will get that fund. So like this, right, you can perform what is called as a merge.